Good morning to everyone in the US, Canada, North America. Good afternoon to all colleagues in Europe, and welcome to our webinar on drones, Rising the Bar for Facility Management and Maintenance. I'm René Moser, the EU and International Affairs Manager at ASFA, the Austrian motorway operator. I'm involved in several IBTTA committees and will be a member of the IBTTA board as of January 2020. And I'm more than happy I'm the moderator of today's webinar. Presenting today, we have 4 experts on this topic, who I will introduce before they speak. Everyone has approximately 13 minutes for his presentation. We also encourage you to submit questions in the questions panel as they come to your mind during the presentations. Before we begin, I would like to go over a few logistics. All participants on today's webinar are on mute. This webinar will last approximately 75 minutes. We will post the slides and audio portion of this webinar on the IBTTA website by the end of the week. Questions will be addressed after we have finished all presentations. If your question is for a specific panelist or you wish all panelists to address the question, please note that in your question. You will only see the question you are asking. At the end, please take the time to answer our brief survey at the close of the webinar. Now it is my great pleasure to hand over to Malika Seddi, our IBTTA International Vice President and Chair of the IBTTA International Committee. Malika is Director of International Affairs and Customer Service in ASFA, the Association of Toll Motorway Operators in France. Malika, the floor is yours.
Thank you very much, René, for the kind introduction. And I would like to thank you all for joining us today's webinar. So we have more than 140 people who have signed today's. And we are really delighted to have so many people from all over the world joining us. For the ones who are not familiar with IBTTA, I would like shortly to recall main outlines. IBTTA is the global organization for the owner and operation of toll facilities and the businesses that serve them. And one of the IBTTA priorities is to provide expertise and also be a platform for sharing knowledge on the range of relevant topics that affect our business. And from that perspective, the International Committee have set up a series of webinars to allow people to exchange and discuss on various topics. We had one of them last June on the managed lanes, and it was a very successful one. And today's webinar is jointly organized by the International Committee and also the IBTTA Emerging Technology Committee Working Group on Drones, which is chaired by Mike Davidson. And I will now give back again to René the floor in order to introduce our 4 great speakers of today. So René, the floor is yours.
Thank you, Malika. Now I will give the floor to Mike Davidson, the chair of the IBTTA Working Group on Drones. Mike is a Senior Traffic Operations Project Manager at the Pennsylvania Turnpike Commission. He has over 10 years of traffic engineering experience and has been managing the Pennsylvania Turnpike Commission's drones program for over 4 years. Mike, the floor is yours. Please remember to take yourself off mute.
All right, thanks, René. As René said, Mike Davidson, and I've been managing the Turnpike's drone program for the past 4 years. Actually, prior to March of this year, I performed this role as a consultant, and since then I've come on board and am now a full-time Turnpike employee. So first, I'm going to just use a few slides to give an overview of unmanned aircraft systems, UAS, or drones as they're commonly called. I'm sure everyone's aware in some respect about drones, but just to get into a little more detail. First, an unmanned aircraft system is comprised of 3 different components: the actual aircraft, the remote control system, and then the communications system that links the controller to the aircraft. And most systems use the 2.4 or 5.8 gigahertz band of the spectrum to communicate between the controller and the aircraft. The aircraft can be operated manually by a remote pilot, or it can fly automatically by programming a flight path into the system before it's flown. And there are 2 different subsets of drones: fixed wing and multi-copter. Fixed wing aircrafts are predominantly found in research applications and military use, and while most commercial and hobbyist drones are multi-copters. So I'm sure if we all sat down together and thought about it for a few minutes, we'd come up with hundreds of ways that drones can save time, reduce costs, and perform tasks in a safer way than conventional methods. So it's no surprise really that drones are exploding in popularity all over the world. Both the FAA and the European Commission expect the drone market to increase substantially, as shown there in the bullets. And of course, this will transform the transportation industry like we've never seen. So now that the stage is set, we'll take a look at what IBTTA is doing related to drones. First, IBTTA established the Emerging Technologies Committee, which investigates and analyzes technology-related issues, topics, and trends, and informs membership about these emerging technologies. So within the committee, there are subcommittees or working groups, and we're charged with developing white papers. So in addition to drones, there's a subcommittee on big data, connected automated vehicles, et cetera, and all of us are developing white papers. Here are the members of the drones working group. We aren't the largest group. I think actually we're the smallest working group, but I am glad to say that each member has participated in the calls that we've had and contributed to the white paper, which we're just about finished and we started working on a few months ago. I'd like to point out the efforts of Frank Velez. He's been the liaison for each working group to the Emerging Technologies Committee. And I'm sure at times he's felt like he's been herding cats, but Frank's been doing a great job, and he's been a huge help to our group and all the others. So looking at our white paper, it's a guide for getting started building a drone program at an agency. We recognize that it's difficult to stand up a program, and it can be a daunting task, don't know where to start. So we just want to provide some guidance and things to consider when getting started. So here's the outline of the paper, and over the next few slides, I'll give a brief description of each section. So first, obviously, we have an introduction, but within that introduction, we also have a quick guide with some links for further reading about drone technology, rules and regulations, and other guides on building a UAS program. Next, we give some use cases to read about and give you some ideas on how to use drones at your agency. And the next presentations will actually go into more depth on some of the use cases. So I'm excited about that. But anyway, then we give an overview of the technology and some things to consider when purchasing a drone. This ordering of the sections is deliberate because we want agencies to think about how they would use drones first, then procure the equipment that will meet that purpose. It could be easy to see what someone else is using and just buy that, but it might not be what your agency needs to accomplish its mission. So let the use cases drive the technology and not the other way around. Next, we have a section on pilot certification and what remote pilots must know or should consider when operating drones. So for example, the chart on the right is a risk assessment matrix used to evaluate different potential hazards during an operation. And then we get into some of the standards and regulations for operating drones, both in the US and in Europe. So the diagram on the lower left is actually a new framework that's been recently released, and it's showing different airspace categories for drone operation in Europe. Next, we get into some of the behind the scenes considerations. For example, do you want to have certified pilots on staff, or should you contract out all drone services? In addition, we talk about right-of-way and right-of-way infringement. It could be a delicate subject because of possible negative public perception. If you do fly over private property, even if it might be technically legal. So we talk about that. We give a checklist of things to consider before flying a mission, and we review some things to consider about insurance and insuring your program and equipment, and we suggest requiring consultants, contractors, and other third parties to carry an insurance policy. So while these things might not be the most exciting part of a drone program, they're arguably the most important. So after the program administration section, we talk a little bit about major research projects within the United States and Europe. And many of these projects are focused on drone traffic management systems, which many believe need to be implemented before we see widespread drone delivery systems. So it'll be interesting to see how these projects pan out. Then finally, we wrap things up with some recommendations moving forward. And to find out what they are, you'll have to read the white paper, which should be released early next year, along with the other working group white papers. So with that, I will hand it back over to Renee. Thank you very much for your time.
Thanks a lot, Mike, for this great overview of the working group and also for introducing us to the drone subject. Now it is my great pleasure to start our best practice examples. The first speaker is my astronaut colleague, Thomas Steinbrücker. Thomas has worked with ASFA since 2002. Currently, he is a member of the Asset Management Engineering team and ASFA's expert on drones. Thomas has been involved in drone projects since 2015. Thomas, the floor is yours. Please remember to take yourself off mute.
Thank you, Renee. Ladies and gentlemen, good morning and good afternoon from Austria. It's a pleasure talking to you today. My name is Thomas Steinbrücker. I am part of the asset management team at ASFA. Today, I want to give you a short overview about one of our first UAV projects. The project goal was to establish, to analyze, and to evaluate the general potential of drones. To get more detailed and specific information, this project took place in the field of asset management only and was processed in 2017. Afterwards, other projects depending on different fields and departments, such as maintenance or incident management, followed. So for the asset management, we tried to figure out where we can get out the maximum support and added value for our operative processes and where we could become faster and more efficient. For sure, one of the main issues is to minimize all risks with the knowledge of more and better data. And as well, increasing the safety of our staff by avoiding to walk and to climb in dangerous areas. The project, as you can see, was set up in 5 main parts, starting with the analysis of the requirements, followed by concept and field testing phase. The main part was the whole evaluation, followed by recommendations for the productive implementations, as well as the right wording for tender offers. We figured out about 28 different potential applications for drones and took a hand of them to evaluate in detail and to establish in our processes on the first step. The green colored application, as you can see on the slide, are optimal areas for UAV operations. To use UAVs there is quite efficient and can be a perfect auxiliary tool to common inspections. So for example, we found out that the steel constructions can only be inspected by drone to a limited extent, as hairline cracks can only be recognized to a certain degree with today's standard equipment. Tunnel exhaust ducts, horizontal or shafts vertical as well, are unsuitable for the use of drones, as flying creates lots of dust turbulences and therefore good pictures can't be taken. Furthermore, exhaust ducts are being split into different sections, which makes it impossible flying through the whole facility at once. So it's better to use ground-based or cable-based sensors or cameras, for example. On the next slides, you can see some impressions of selected essential test applications we tried out in detail during this project. For example, arched bridges, like this one on the Puck Pass in Styria. The challenge for common inspections is the bottom side of the arch, so you can't get there without quite big effort. UAVs with top-mounted gimbals and cameras do so without any problems. So the focus at this test application was laid on photo documentation of these areas which are difficult to access. We tried to find out which data coverage is possible. Also, in this and all the following test cases, we checked out which hardware equipment, which sensors and cameras are necessary to get all the information, the proper quality we need, and that we can pack this information into our tender offers. So the picture on the left side below shows a pillar of one of our biggest bridges, laid over by a mapping of cracks and other noticeable damages found out by artificial intelligence and computer modeling. With the right equipment, you can reach a detection quality up to 0.3 millimeters and fewer. On the next slide, you can see 3D visualization of a mudslide with rubble. With before and after flights, you get information about rubble volume, measurement, and an analysis of the area's change over the years or after an incident by the repeatability of the UAV flights. Another example where we can check the security and functionality of our constructions are rock face stabilizations, avalanche protectors, or flood barriers. Here are the short impressions of the 3D modeling and the mass balancing of the mudslide and the rubble inside. All of the applications which are far away, hard to reach, or within a quite big area like the mudslide shown before, or as another example, the top of an enclosure, as you can see here, are predestined for the help of UAVs. So in contrast to that, exhaust shaft of tunnels, as mentioned, are the proper use case in our experiences. So here you can see a short list of, as we think, the biggest advantages using UAVs as a helping tool. So you can guarantee maximum safety due to early detection of anomalies and changes, also in parts of the building structure which are difficult to access. There also is the opportunity for seamless surveying and documentation and obtaining valuable additional information. There is the fact of exact repeatability of the server and analysis whenever you want this to do. And all in all, it's an improvement at the completion of the quality of inspections and documentation at all. Using UAVs is decreasing the danger to staff by reducing or avoiding their presence in dangerous areas. And finally, one quite important point for us, the reduction of the need for lane closures due to the reduction or lack of need for the use of conventional climbing aids for like ladders or bridge inspection vehicles. For sure, there are some limitations using drones as well right at the moment here in Austria. So for example, the legal framework conditions in Austria are quite strict, and there is currently no official permit for flights directly above railway or highway tracks. It is also forbidden to fly outside the visual line of sight at the moment, which means you have to act within a radius of 500 meters. And there is the law, no flights directly above larger crowds of people. So, and this is given by all the people in their cars on our highways. Furthermore, there are some environmental conditions like very strong wind, heavy rain, very cold temperatures, or the proximity of moving traffic, which causes quite a big suction effect. Last but not least, the cost and effort. Using an UAV isn't always the most economical way, especially if the building structure is easy to access and not quite big. So you have to look before, where UAVs are really the best helping tool for the inspections to be done. On my last slide, you can find the conclusion for our department, asset management, on the one hand, but for other departments and even divisions of the company on the other hand as well. So UAVs are proper tools to support our asset management staff by fulfilling their inspections and to get more detailed information about the inspected object. For standard objects with simple access or small objects, for example, we usually don't expect big economical benefits. Under certain circumstances, you can find some economic advantages due to smaller impact on traffic even there. For special objects, hard access and very big objects, the biggest advantages are the detailed and comprehensive inspection options due to the new technical opportunities. Safety and availability are getting better. Within the context of our following inspection and examination plans, the initial deployments of drones has been established for buildings and structures where an advantage can be expected. So on the basis of the practical experience obtained during the last year, actually our internal processes are going to be defined and adapted in some points. For example, we plan to establish a central competence unit where all the US activities at ASFA are coordinated, accompanied and monitored. This is also quite important to ensure that the big data we get is integrated in our systems and long-term usability is guaranteed. In the meanwhile, other departments, also in different divisions of the company, are involved and preparing to use UAV technology as well. So thanks for listening, and additionally, there will be a short teaser video of our project as final overview right now. And Cheryl, can you please start the video?
Thank you, Thomas. Now let me hand over to Manuel Groh. Manuel began his law enforcement career in 1986 as a Maryland Transportation Authority police officer. On December 1st, 2016, after 30 years of dedicated service to the citizens of Maryland, he retired at the rank of captain. On February 1st, 2017, he rejoined the Maryland Transportation Authority Police as a police civilian and currently serves as the Executive Officer, Chief of Staff for the current Chief of Police. Manuel, the floor is yours. Please remember to take yourself off mute.
Thank you, Renee. It's a pleasure to be here today, and before I begin, please let me introduce what our department is. Our agency is the 7th largest law enforcement agency in the state of Maryland. We currently have over 600 sworn and civilian professionals that work at our facilities across the state of Maryland. We're responsible for law enforcement at our Maryland Transportation Authority's highways, tunnels, and bridges. And we're also contracted to provide law enforcement services at the Baltimore-Washington International Thurgood Marshall Airport and the Port of Baltimore. A few photographs on the slide show you the area that we're responsible, where our drones also or utilize services at an event of a collision. Now, challenges to our roadway openings for our agency. Over 34 years of experience, we've notified 3 major areas that cause us a delay of getting our traffic open. Treating the injured, we know our first responders arrive on our scene, our police, fire, emergency medical services, and treat those injured and remove them from those locations. The second challenge is processing the scene by our collision reconstruction unit. We know by major accidents involving serious fatalities or injury accidents that we do not move any vehicles until our collision reconstruction unit arrives on scene and begin processing the evidence. And then removing vehicles and cleaning up the debris from the roadway after our collision reconstruction unit has cleared. Currently, right now, we already have our construction individuals, our maintenance personnel, our tow trucks on scene, ready to go in a moment's notice when the roadway's back open, so we can get those roadways open clearer. The primary purpose of our small unmanned aircraft system or drone program is primarily efficient traffic management. Our drones are used by our collision reconstruction unit across the state to document and collect evidence of serious and fatal collisions through the use of 3D mapping, or PIX4D. Our program was fully implemented in November 2017, and to date we have processed numerous serious traffic collisions or fatal accidents using our drone program. In each case, we have significantly reduced the amount of time it takes to properly map a collision scene and regain the normal flow of traffic. Our collision reconstruction unit, which is a total of 17 members, trains monthly on our drones to ensure everyone stays familiar with the program, which allows us to be more efficient on the scene. Our deployment of a drone scene requires at a minimum a pilot and a spotter for all flight operations. Our accomplishments: we have an approved policy that was vetted by our Attorney General's office and our senior command staff. We have COAs, or Certificate of Authorizations, from the FAA on all of our drones. We have a waiver of operation from the FAA, which allows us to operate in controlled airspace within 5 miles of BWI Airport. We worked with the FAA at BWI Airport and deployed a working agreement to operate within a 1 mile radius. Basically, our patrol cars at the airport have radio towers, so we can pick up our portable radios and speak directly with the tower anytime we have to utilize a drone near that airspace at BWI. We worked with the American Civil Liberties Union, the ACLU of Maryland, on our program. We wanted to make sure our program is transparent and there's no privacy concerns from the citizens that we serve. We currently have 2 drone instructors, and 8 of our collision reconstruction unit members have their FAA UAS remote pilot licenses. And we currently have 3 drones, a Dragonfly X4P, 2 GGI Phantom 4s, and we're finalizing the procurement of 2 new GGI Matrices to add to our fleet of drones, which we have strategically placed throughout the state of Maryland. Sharing our vision, we work with our partners on the challenges and rewards of the drone program. There is no perfect system utilizing drones, and it does have its limitations for collision reconstructionists. For instance, high winds, storms, snow, ice, and darkness. There are technologies that's being developed to allow us to utilize our drone at nighttime to capture the images that we need. However, we're still developing technologies to make that process a lot quicker. And proven results. We know right now that when our team arrives on the scene, we can deploy the drone usually within 5 minutes and have the scene processed within 10 minutes. We have proven that we can reduce our collision scenes by 50% of the time it took in the old days. For a collision scene that used to take an hour to process, we can process that scene in 10 minutes, which allows us to open up our roadways quicker. By doing this is a huge cost savings, and also increases customer service by not having the police have to delay traffic or hold traffic more than really need to do so. Now, our primary purpose, again, with these drone units is to enhance the collision reconstruction unit. By conducting mapping of collision scenes and incident scenes using our drones from the air, we have shown that we can capture the data faster and as accurate as a land-based mapping software. Now, we do realize that with climate weather, with snow, In heavy rains when the drone cannot fly, we do utilize our old system, which is a laser-based Faro station, in events that we can't have the drone present. But the method has currently resulted in a quicker CRU investigation, since mapping our area has always been one of the biggest delays that we've had to handle. And since our drone program has been instituted, 100% of our responses that we utilize the drone has shortened our lengthy investigation time by 50%, which allows for a quicker roadway opening for the public. Right now, we have a short video clip that I will show you to give an overview of our collision reconstruction members talking about the program and the success that it's had. If you would, please play the video. Thank you.
I'm Corporal Michael Lamont with the Maryland Transportation Authority Police. I am in charge of the collision reconstruction unit for our agency, as well as in charge for our UAS team. The UAS team is comprised of 6 members of the collision reconstruction team, and what we are certified in is to fly a unmanned aerial systems aircraft to map collision scenes. The time is the biggest difference. For a ground-based mapping system, it would take us, for a large-scale collision scene, it would take us close to an hour to an hour and a half to map a full scene, and that's probably about 8 scans. But for the UAS, to map an area that large, it took 9 minutes to fly the entire scene, and total time was 20 minutes.
When you're talking about a general use of the ground-based scanner is going to take us a minimum of an hour and a half, and at minimum a single scan would take about 12 and a half minutes. So you're talking about cutting down on scene time and getting our roadways reopened a lot sooner to get traffic moving again.
I think it's a great tool. It's definitely a time saver.
When I started in the unit 2 years ago, we were only using the Faro scanner, was our ground-based scanning program. So to get this technology and to be able to cut down on our scene time as much as we're able to do so is pretty phenomenal for me.
And thank you all very much for your time today.
Great insights. Thanks a lot, Manuel. Our last speaker for today is Lars Pedersen. Lars is CTO and Technical Director of Sand and Belt Holding, a major bridge and tunnel owner in Denmark. He has significant experiences within the fields of innovation and change management, planning and construction, database digital asset management, and maintenance of major bridges and other large infrastructure projects. Lars is also a member of committees and working actively in international organizations like the European Association of Motorway Operators, ASECAP. Lars, the floor is yours. Please remember to take yourself off mute.
Thank you, René, and good afternoon from Denmark, and for the opportunity to present how we do photographic asset inspection by drones and artificial intelligence of images in Sund and Belt in Denmark. Just a second. There we go. Just to show you my location, as you can see from the map of Europe, Denmark is a small country in Northern Europe. However, we have a lot of islands along coastline of approximately 7,000 kilometers and a lot of bridges. We're linking Central and Northern Europe via the 2 major fixed links in Denmark and Sweden, which comprises both bridges and tunnels of 18 and 16 kilometer long distances. And we're doing a tunnel to Germany, an 18-kilometer long project with a total value around $10 billion US. This is the content of my presentation. I will give a short presentation of the Storebælt bridges, briefly show our approach and go through the drones, the photographic image, and the image analysis with artificial intelligence, and finally the results that we have. The Storebelt bridges, I have shown the main figures on this slide. The bridges have a required lifetime of more than 100 years, a lot of safety requirements for ships and cars, and a great focus of an environment due to the location. Our focus of digital asset management can be understood in this context of the criticality of the assets. In our organization, where I'm responsible for the technical area, we have high ambitions. As you can see on this slide, we have ambitions regarding efficiency, the 2% per year, maintaining a good quality and accessibility to our customers, and the long-term focus of the total cost of ownership, and to optimize the knowledge and technologies. We are trying to get as much data as possible, to structure it in models and to use it by analyzing it with artificial intelligence. I will now explain how we are retrieving and using data from drones and robots. On this photo, you can see a drone below the bridge and a roadmap of different robots that we are investigating. We use drones and robots to take photos that we can retrieve data from, and in the long run, perhaps we can make them perform other operations. So if you can start the video now, and please unmute it, I will talk over it. Inspection, where we set up scaffolding or raising people in rappelling equipment. There you see to the left the inspections we did before, and to the right how we do inspections at the moment. Just a second. I'm not able to shift the image. There we go. We are getting, with better methods and better data, we can have a more predictive asset management and have lower costs. So we improve the inspection methods and we improve the data in order to get this. The solution we use is called PAI, Photographic Asset Inspection, and in this process, I have a map showing how the drone captures the images that are imported and organized by the photographic asset inspection tool that we have developed together with Microsoft, and how the damages are automatically detected. In order to learn the computer algorithm to detect damages in the image data, there's a human validation by a concrete expert from the detected damages. You can use all kind of photos, and however, due to the quality, overcast weather is preferred. And the photos will be organized by geographically by using the GPS location. And the algorithm will analyze and categorize the photos into different damage categories, as you see on the slide, and also how severe the damage condition is assessed. This shows how the algorithm can detect damages from the images. The confidence for the damage detection is very high, and we are going to let others use the algorithm and the tool. It will be sold as a small app to be used for inspections. It's currently being used and tested by other Danish infrastructure owners and their assets, because the more data we can get into it, the more accurate results. You can make your own notes and annotations on the in the reports, and you can create reports like in a PDF format and share them with others. And this is an overview of the system where you capture the photos, you store and organize them, they get analyzed, and you can report and export the results. These are our results so far from all our efforts with optimizations and better data. For our OPEX, the ambitions to reduce maintenance and operations costs are more than on track. On quality, we are measuring the lifetime. We now believe to have increased the lifetime to more than 150 years. We had promised more than 100 years. Further, we measure the condition of assets with the data in order to see that the conditions are improving. And with the data and data models, we have much more knowledge regarding the data and the assets. On the CAPEX, we have reduced the renewal costs from the original budgeted 50-year plans down to around 55% of the original budget. And finally, in the new projects that we are working with, we improved the total cost of ownership with the data models that we have. This was my presentation, so thank you very much.
Now we have time for some Q&As, but before, I really want to highlight that for me, drones are really a great and promising tool for the tolling industry, because they help us to better maintain our infrastructures, to extend the lifetime, to help us to get more efficient. We need less lane closures. That means they help us to keep the traffic flowing and to continue with the generation of toll revenues. Also, what Manuel told me is really a very promising future aspect, that we use drones for crash reconstruction. That means after an incident, we are much faster to reopen the lanes, the streets, the highways for traffic, and that will help us a lot to keep the traffic flowing and to continue with our core business at the toll collection. Now let me turn to the Q&A session. And I have to say, the first question I have for all our speakers comes from our IBTTA president. And we discussed this issue during the IBTTA annual meeting in Halifax a couple of days ago. And the question is, how do you think about drone operations above and close to our infrastructures? We really discussed that we think we need some rules and regulations. What do you think? What are your experiences? And also how you can minimize the distraction to the commuters on our network, so that they are not getting afraid of drones when they are flying above our infrastructures, and we would risk the traffic safety. Maybe I will hand over this question first to my colleague Thomas, and then maybe to Manuel, and then to Lars.
Okay, thank you, Renee. So for the first thing, right now we normally try to be as far away from traffic as possible with our flights with drones. And we try to fly under our objects or beside them, or when we have to get into the closer of the object, we have to close the first lane in case that the object is quite too near to the traffic. And so furthermore, it's forbidden by law or quite hard to get an approval to fly over directly above traffic. And I think that's right. So we have just to deal with two possibilities at the moment. We can pre-inform the customers by signs or early warners that there is a drone flying right now in the area, or since there may be a curiosity problem, then we tell nothing and try to be as far away from traffic as possible. And for your question, I think that the highways should be no drone zones at all. And actually, we are discussing this with our flight control and the lawgiver in Austria as well right now.
So Manuel, what do you think about this question?
Yeah, I think it's important. I know in the U.S., our biggest challenge is with hobbyists and with media outlets that want to fly over our bridges and tunnels and get the latest and greatest. But the challenges is keeping and ensuring that those drones are not directly overhead of our motorists or the walking public. Basically, I think working together with the FAA here in the U.S. has made things better, but certainly I think more needs to be done. And I think sitting down at a table with a lot of professionals within the U.S. and out of the U.S. as well, too, to look at these areas, because there's limited challenges that we can do to track these individuals down that do violate that and fly over top of the motoring public. But it's something that we all need to be aware of, because it's not just here in the U.S., it's everywhere. But certainly working with our local, state, federal, and international partners to come to a table to make sure there's a good set of rules for everybody, I think would make things a lot safer for our public.
And Lars, your opinion on this question?
Well, we have the same problems as you guys are mentioning, and however, our bridges they are offshore, so the major problem is, of course, flying over the traffic below. We are temporarily permitted to do that, for example, when we do inspections of the cables as well, and the top of the pylons on the bridges. That is also important for us to be able to do inspections there. We have made our own setup for approvals, as we have authority in the area, and we have one of our guys who's doing the approvals, and we have made a setup with some criteria for approvals. Yeah.
Thank you so much. Now I want to ask also Mike if this this question will also be part of the white paper. And an additional question, can you please tell us again, when will the white paper be available for download also for the IBTTA members? Thank you, Mike.
Thanks, Renee. Yes, we do touch upon this in the white paper in the right of and the right of way section, and yeah, I for our agency, I echo everything that's been said. We've had some issues, and I think it'll be interesting to see how the research on the drone traffic management develops and what comes out of that. As for the white paper, I believe it will be released sometime early in 2020. So be on the lookout for that. along with the other white papers from the working groups.
Thank you very much, Mike. Now we have a little bit a more technical question, and it is about, are there any examples for inspecting structural steel on cable stay or other type of bridges with steel structural components? What are the constraints? Are drone inspections adequate for paint inspections on steel? Does any one of the speakers have any experience with that special question concerning this type of bridges? Thomas, have we already tried to work also with that kind of bridges?
Yeah, we tried to fly at the steel bridges as well, but so we figured out that the steel constructions can only inspect it by drone to a limited extent because of hairline cracks, and these are important to know or to find out, can only be recognized to a certain degree with today's standard equipment, and you have to take really high-end equipment to get, for example, at concrete bridges, detection quality up to 0.3 millimeters, and at the steel bridges you have to get a detection quality fewer, and that's quite a problem right now. But I think we are at the beginning of the search, and we will find the technology which can manage this in future.
Thank you. Maybe Lars, you are operating huge bridges in the northern part of Europe. Do you have any experience with that question?
Yeah, René, we are doing visual inspection of our cable hangers on the main cables, but I agree with what Thomas said. It's visual inspection we can do with today's equipment. However, we are looking at different ways of changing that, for example, to do some thermographical inspections where you can see the difference, the temperature differences will show some differences in the steel that we could use. So we are considering that, but we haven't got any results yet. So basically, I agree with Thomas. With today's equipment, we don't have enough experience in steel except from the visual inspection. But for the cable hangers, we can do visual inspection and use it for something.
Thank you very much. I'm not sure, Manuel, if you can add something on this question, but I would have a question which I think is addressed to you. And the question is, would drones have an application for replacing or complementing courtesy patrols for roadways?
Well, I think it could assist. We haven't thought about that, but certainly being able to fly long operations can assist our courtesy patrol. We do have those throughout our highways and bridges and tunnels, and I would say it's something worth looking at for the future.
Thank you. Now I have another question for our bridge experts. And the question is, did you have any experience of inspecting inside the concrete box by drones? Thomas, have you already some experience?
We already tried this as well. There are drones and special UVs with a cage around it, so they can contact inside if there is an accident, for example. But it shows up that it is more efficient that you are using the standard equipment like robots or like cable cams or such things.
Lars, do you have any experience concerning this?
It's the same with the tunnel exhaust ducts, for example, or the shafts, the vertical shafts. We try this as well with a cage drone, and this is one possibility. But cable-based sensors or cameras get the same effect.
Thank you for sharing all these insights. So we have another question, and the question is, Do you foresee the adoption of drone inspections resulting in the same frequency of inspections performed at a greatly reduced cost? So the question is, what do we expect concerning the costs? Or will companies continue spending about the same amount of money on inspections while increasing the frequency to collect higher density data on bridge aging? So if we sum up this question is, do we want to reduce costs, or will we try to get better and more data of our bridge infrastructure or infrastructure in general? What is your opinion on this? Let me start again with Thomas.
Okay, me once again. The cost thing is a thing. I think at first there will be more cost. It will be more cost intensive. To get all the information you need to fly with a drone. For example, in best case, you have a flight plan for every object in your highway network, and that generates costs, for example, at the first moment, and to save money will be the second or third step. Then first you have to invest, I guess.
And Lars, your experience or your expectations? I think you already presented some really great numbers.
Yeah, we benchmark our costs and with a normal inspection compared to an inspection by drone on our pylons that are 254 meters high. So we can see that in that case the costs were 10 to 15% because it's both the speed and the ease to get up and down is lowering the costs, so we can do it much faster. I believe that in the long run we will probably do some more inspections because we get better data from the drone inspections, and we can follow the progress or the development of damages, and that is very interesting for us to use that data to be more predictive to the lifetime of our constructions and to do repairs and maintenance at the right time. So I believe the data itself will also contribute to the cost, to reducing the cost further to the direct reduction of costs.
Thank you. Mike, do you want to add something based on all the discussions we had in our working group on drones?
Sure. I don't know if using drones would lead to more inspections. That's a really interesting point. I know here in the United States, I'm not a bridge engineer, but I know that these standards require a hands-on inspection. I don't know if it's every 2 years or what the frequency is. So that's the minimum requirement, and it seems like using drones can help eliminate problem areas and not necessarily totally replace the hands-on inspections that are required.
Thank you. I think, Manuel, for you the situation is a little bit different because you use drones to keep the traffic flowing and to do all the paperwork and to analyze the accident sites afterwards based on the data you collect with the drones.
Yeah, that's correct. It's primarily a 100% use of the drones is to make sure of mapping the crash scene, collecting that evidence, and getting that roadway open to keep these cars moving on our highways. Don't have much insight as far as an area expertise and as far as the bridge inspections. I'm sorry about that.
Thank you. My next question would be, I think, one which is interesting really for everyone who is not using drones at the moment. What would be your recommendation? Should agencies invest and buy and operate their own drones? Or do you think it is better to just define the use cases and to outsource this service? Maybe this time we will start with Lars.
Yeah, I believe that the flying we have educated some of our own people to become drone pilots, but on the other hand, the drones are getting more and more technically advanced, and they will be more and more expensive. So I believe it will be in the long run, it will be a commodity where you can buy it from different suppliers and also use the algorithms that are available and buy them as you buy a lot of other things. So I don't think that everybody will have to develop their own. I think you will be able to buy it as you buy different other things. Yeah.
Thomas, what would be your recommendation to agencies in the tolling business?
So I'm with Lars there. So at the moment, ASFINAG, for example, has no own UAVs. Right now, we work together with external contractors, and I think it depends on the difficult level of the flight. So there in future, it's maybe possible to do some of the use cases by our own, and where you have to have very big knowledge and big drones and big technology. There you take the contractors, the external contractors, for example. So it's, I think it should be a mixture.
Manuel, is the situation similar for transportation authorities based on your experience, or would you recommend something different?
Well, I would recommend for anybody that has their own internal police department that's responsible for handling collisions on your roadways, I would fully recommend a drone program for them that does collision reconstruction. Now, if you contract or have other law enforcement agencies that handle accidents on your roadways, that's a different story. But if you're able to control, manage, and fully fund your own police department, and their responsible is to clear those roadways, I say that this program is essential, and I will guarantee you that it will save you 50% of the time collecting the evidence at a scene to get that roadway open. We've documented and proven that it is successful here. But again, it's if you have your own internal police department that you can control and fund that's responsible for those crashes, I think it's a win-win situation there.
Thank you so much. So I think we have two more questions. The first one is for Thomas and Lars. And the question is, have you found value in using thermal imagery for finding bridge defects? And is it cost effective compared to regular optical photo or video detection? Thomas, do you have any experience concerning this?
So right at the moment, we have only test experiences with thermal cameras. So there are no really productive flights right now with this camera, with this kind of sensor.
And your experience, Lars?
I don't. We don't have finalized our tests either. So we are also looking at it. But I know that some of our Japanese bridge colleagues are using thermal cameras and have more experience on that.
Thank you. Maybe Mike, have you discussed this also in the working group, and will be there a recommendation also in the white paper concerning this?
Yeah, we do touch on thermal and infrared cameras in the technology section. For me personally, in the Pennsylvania Turnpike, we haven't had any experience with either us or contractors or consultants using thermal cameras.
Thank you. I think we are coming now to the last question, and it's again a very important and crucial one. It's about the link between the data the drone is capturing and how we proceed with this data. So are there commercially available artificial intelligence software for evaluating drone captured data in the market, or do organizations and agencies develop their own custom built software? Maybe let's start with Lars this time.
Yeah, we have a beta version together with Microsoft that we are testing with other Danish users or bridge owners and infrastructure owners. But I believe there are other commercially on the market. But of course, the more, as I mentioned previously, the more data you get into these systems, the better the artificial intelligence will be, and the more accurate data we will have as owners. So it's our interest to share it.
Thank you. Thomas, what do you think about this?
I think this is quite a good question, because it's really important to ensure and to make sure that the big data we get is integrated in our systems. And the flying is one part of the whole action, and to get the data and to guarantee the usability is the other side. And for the algorithm, there are a lot of algorithms, I guess. There are external contractors who try to make them better and better right now, and so this is in the part of the research right now, I guess. And we have to figure out where the best algorithm is. And as Lars said, the amount of the data makes the algorithm better day by day, I guess.
Thank you. Manuel, do you want to add something concerning this question?
No, not too much, Renee. Basically, the data we're collecting is for collision reconstruction, and we download and save most of that on our Pix4D and Surveyor software. So it's our data collection is just restricted to collisions.
Thank you. Mike, anything you want to add concerning all the knowledge you gathered in the working group?
No, and unfortunately, we don't really touch on data management in the white paper. I think data management could probably be a white paper in itself, but I could definitely see other committee members while the white paper is in review asking us to add a small section on that, because it's definitely see different agencies unsure of what to do with all of the data that is collected.
Thank you so much. That brings us close to the end of this webinar. I want to thank once again all the speakers for their great insights and also for sharing all their experience with us. Thank you all also for your questions and for your participation today. We would appreciate your feedback and ask you to answer the short survey that will appear on your screen when you exit.